Always love teaching conferences because I know I'm with a bunch of like-minded people, all teaching the hardest course, I think, which is Principles of Economics. And so just a little bit about our experiences at George Washington. And a lot of what I'm going to be talking about, I know that all of you have experiences with as well, very similar experiences. So let me go ahead and get started. So the problem, which I'm sure is familiar to everyone here in this room, large classes with a very diverse student body. We have about 2,500 students who come into GW every year as freshmen. Out of that 2,500 students, 1,500 come into economics, and they're all registered for Principles of Economics. They are students from the School of International Affairs, from the business school, from public health, organizational sciences, people in engineering taking it as an elective. So the group is very diverse. We're in Washington, D.C., so we have a very international crowd. And so we have Chinese students, Indian students, people from Eastern Europe, et cetera. So it's diverse in every single way that you can imagine. What we have found over the last several years, I started teaching at George Washington in 2010. Actually, before that, I was here at Vanderbilt. Is that students are coming in academically unprepared for college-level work. And often you would hear students in the classroom saying that they find principles of microeconomics, economics is just hard. Economics is hard, and they can't get it. So one of my colleagues, the first semester after I taught there, said, I wonder what the problem actually is. You know, we have enough people coming into our offices saying, you know, I'm not really a math person. I don't get this because I'm not a math person. And, you know, you're asking me to do algebra and understand graphs and all of that. So the question was, is it the econ? Or is it the math? Or is it something else? What exactly is going on? And let's do some assessment. So part of what I want to share with you today is not just how we're dealing with this math issue, but talk a little bit about assessment and the value of assessment. So what did we do? We did some formative assessment. And formative assessment is done at the beginning of the semester where we do some diagnostic testing. And so we said, let's just see whether, you know, we just have this in our heads that students are weak in math or whether they're actually weak in math. So we decided to give them a short, small test. We didn't allow them to use calculators because we really wanted to know what they knew and what they could do and what they couldn't do. And we said no calculators, no multiple choice. It was all open-ended questions, 20 Algebra 1 level questions. That's the prerequisite for our class. It was 45 minutes. We gave them plenty of time because we hadn't given them calculators, and we knew that some of them would be slower at doing the computation. And we made it 5% of their course grade. So we first thought, let's just go ahead and give it to them, but then we thought they wouldn't take it seriously, so we made it fully 5% of their course grade. And here are the results. So the questions that we asked them, we didn't ask random Algebra 1 questions. All of us had been teaching micro and macro for a long time. We know the kinds of skills they need for that class. So we asked them only for those skills that they were actually going to be needing in the class. So arithmetic, we asked them about questions on order of operations. Do they know how to deal with fractions? Do they know how to deal with decimals? Algebra, can you solve for y in terms of x? We asked them some word problems. You know, two people go to a restaurant. One orders, you know, they both order hamburgers and French fries, and hamburgers are priced at this, and you know, French fries are priced at that. What do they pay totally, etc. Simple problems. Geometry, the area of a triangle for welfare analysis, rates of change, which we look at growth rates in macro all the time. We find students are so confused about that. Graphing, slope of a straight line, providing the equation of a straight line if you're given a line. And we found that over 70% of our students couldn't score an 80% of this test. And we're assuming that they've already mastered all this stuff because they've graduated from high school and our university has given them admission. So we assume that they know all this stuff, but fully 70% of them couldn't answer these questions. So we knew, as I'm sure many of you have found in your institutions, that we had a problem on our hands. So what did we do? I'll fast forward to, that was in 2010, and I'll fast forward to this year because a lot happened in between, but we don't have the time to go into it. So what are we doing now? Because we still have that same cohort coming in. What we do as soon as they're admitted to GW, the university reaches out to them, advisors reach out to our students, and we give them an online math placement test. We've worked this out with the provost's office, the math department, et cetera. And we have a cutoff score of 61 for 61 out of 100 to get into micro. They're told this in May as soon as they're admitted. They have all summer to take that test. They can take it over and over. They can take it 5 times. If they don't get the score they need to achieve, the system automatically takes them into a remedial module, and then they get another opportunity at the test, et cetera, et cetera. So plenty of time for them to practice and do the work. Then we let them know around August 1st, Blackboard opens for faculty. So at that point, we know who our students are going to be. And we email our students and let them know right at the beginning of August. School doesn't start till the end of August, but we let them know that we're going to be giving them another paper and pencil placement test the first week of classes. We send them copies of previous tests that we've given, and we give them some resources to work with. But we know that if they really haven't done the ALEX placement test and been able to get that score, they probably aren't ready for it. And by the way, this is great signaling because they know it as well by that time. So then by the end of the first week, our TAs are grading these papers. We have our results. And we tell the students, we'll see, for instance, students who scored in the 80s on the ALEX placement exam, which they took online, get a 2 out of 20 on the in-class placement test. So that gives you that there are some students, we don't know how they're taking it, but that always amazes us. And so we then advise them based on the in-class test. If they get above 80% on it and they can do the basic math, we say, you're great, you're good to go ahead and do micro. If they're somewhere in between a 60% and an 80%, we tell them, well, there are a couple of places where you're weak. You might want to start the semester with a tutor. And if they're below a 12 or below a 60%, we tell them to go into another class. And that class is the Principles of Mathematics for Economics. The class was on the books for a couple of years. We had thought about it. We had asked the math department to help us out with our weaker students, and the math department wasn't interested. So a couple of colleagues and I thought maybe we should be thinking about this, and so we decided to offer it. Given the number of DFWs, the percentage of DFWs that come out of economics, we are a large gateway course. The provost's office said that they would fund this course, and so we've started offering it, and that's what I wanted to talk to you about today. So this is what we typically see at GW. You can see from 2012 to 2017, we've been giving this placement on a regular basis. Here's the number of students usually on average that attempt the placement exam is about 1,400 students each fall. Number of students that fail to pass that placement exam is between 154 to 210. The percentage has been so steady. Year after year, semester after semester, we do the placement. The numbers have been steady. It's about 11 to 15% of our students who just cannot get through that test, the basic math. This is this year's numbers. Here are these year's numbers, fall of 2018. Again, another 13%. Just don't know the basic math. There's no way we can teach them the economics in the classroom with the micro and macro since they're so weak. So a large number of students are very weak in basic math. Now think about it from the university's point of view. Almost 200 students are just, what will they do with them? They have to take the introductory class for international affairs. They have to take it for the business school. They have to take it for public health. What are they going to do with these 200 students? We had no other options. Before this class, we were telling them to go to a community college or do some Kumon math or do some online learning on their own. But we know they don't like math. These guys are not strong in math. They're not going to do it. So we were giving them no options at all. Did we do a good job of placing our students? Well, I'd like you to pay attention to the blue bar first. That's the overall score. We collected a lot of data. We collect data by question for all those 1,400 students so that we have a very good idea of what they know and what they don't know. By the way, this information is very helpful to us as faculty going in to teach the course. It is also very helpful to students to know where they're strong and where they're weak. So we're giving them lots of information first week of classes. Here's what we found, that overall, this is arithmetic, algebra, and geometry. We've divided up the scores here. You can see that it doesn't matter whether they're the weak students. The weak students are the column in red. It doesn't matter whether they're the weak students or the stronger students. They're the ones in green. All of them are weak in geometry. So right away you can see that. And then you can just see how much weaker the weak students are. Everyone in red is in the Principles of Mathematics for Economics class. They're the ones who couldn't pass the test. So you can see the test, the placement that we're doing is really placing them well into the two classes. There's a little bit of crossover, There are students in the micro class who refuse to leave it, who refuse to get out of the class despite our advice. And there are students in my class, the Principles of Mathematics for Economics, who actually did well on the test but wanted a slower first semester, so they decided to come into the class. And I had one-on-one conversations with each of them as to why they were there, and then allowed them to stay in the class if I thought the reason was appropriate. So here is the data. The weaker students, these are the stronger students. These are the ones who made it through the test and made it into micro. And you can see their scores. They've passed on everything. You can see they're the weakest in geometry, but even that they've passed. 60% is a pass. Below that is an F. And this is the average score on the placement test. Look at the weaker students who are in my Principles of Mathematics for Economics class. Dramatic difference in scores. They failed everything. On every one of those categories, and that's who is in the class. And we've made a promise to these students that we are going to prepare them for microeconomics and macroeconomics. So this information is extremely helpful to us at the start of the semester to get an idea of who our students are. It's also very helpful for the students to see this and get an idea of where they are before we start. What do they not know? So we looked at data by question. So this is a question on rates of change. So on the vertical axis, we're looking at sales and then time on the horizontal axis. So the question was on rates of change, which you really have to be able to read graphs well to understand that concept. And we asked questions like, when is it that the rate of change in sales is always positive? And which of these graphs is it always increasing? So that was a hard question. We knew the students would have a hard time answering that. This didn't surprise us. We expected it to be the most missed question overall. And this was among the stronger students as well as the weaker students. We decomposed the data to look at who was missing it. Here was the second most missed question, and this was among the stronger students. These are the guys who passed the test, scored above an 80, and made it into micro. The second most missed question. This is shocking. The first question, okay, rates of change, we know is a difficult question. This was percentage change. Percentage change was the second most missed question. And if we're trying to teach things like elasticity, and these are supposed to be our stronger students, this really makes us sit up and think about what the students aren't seeing. Okay, what about the weaker students? Weaker students, it's geometry, it's the straight lines. So most missed question among the weaker students, what is the slope? So they can't visualize what this equation represents, what it looks like as a graph. And then if you invert the axes, they can't visualize what happens to the equation, what happens to the slope. So they have no idea of this. The better students did fine on this question. Here was the second most missed question. We gave them this line and said, write the equation of the line on the graph, and they just weren't able to do it at all. So this was the second most missed question. I mean, of course, when you're looking at the weakest students, they missed everything. They failed everything, but these were the most missed questions. So what is our class about? We are having very weak students in the class. These students don't like math. They don't want to do math. Many of them actually don't want to do econ. They're forced to because they want to go to the business school or go into international affairs. So the first thing we decided when we were going to teach this course was to treat our students with respect and to understand that we were dealing with adult learners who didn't know basic things like how to add two negative numbers. And so how do you deal with students who have that level of math inability? So we decided at the outset that we have to approach this very differently. We can't treat them like they're in elementary school. We decided that these guys don't like math. And neither are we people who like to teach math. I like teaching econ. I'm an economist. I don't want to teach math. I don't know how to teach math. And so I thought I'm not going to get any pleasure out of that. And neither do they want to learn the math, but they have to do econ. And as many of them are interested, actually very interested in econ. They just don't have the math skills. So we thought we're going to motivate and teach the students math using economics, business, personal finance, and current event-related examples, actually very similar to the way Steve is running his class. The questions about why do recessions occur? Why is there inequality? The big questions are what they're interested in. So we said we'll begin with the big questions, get them hooked, and then we'll introduce the math slowly into and I'll show you some examples of how we're doing that. We decided that we would teach the course with a focus on numeracy and understanding and not on computation. So there were two ways that we thought we would achieve that. One is by not allowing them to use a calculator in the classroom. We found that one of the reasons they were so weak in the basic math is that there's so much calculator dependency. So we took a big risk in doing this, but we just walked in and acted like it was natural and said, guess what, we won't be using a calculator. And we told them instead, you won't need a calculator because you're going to have all of us, TAs, learning assistants in the classroom. So the TAs are graduate teaching assistants who are PhD students who are in the classroom with me, and we're doing an interactive class. And I also have a couple of undergraduate students. This is the learning assistant model from the University of Colorado. They're in the classroom as well, walking around helping students solving problems. And so this has been very effective. It has worked very well, surprisingly so. If they know there's someone they can ask a question, and they can ask a question without any expectation of judgment, they will ask the question. One of the things we wanted to teach them in this class was to make mistakes with pride, and we're trying to do that. Finally, we really wanted to change their attitude towards math as well as their confidence in doing math. So I'll talk a little bit about how we're doing that as well. So these were the goals of the class when we started out. What types of questions? How do I begin by introducing addition in the classroom? I know that there are people in the classroom who can't add two negative numbers, who can't add a positive number and a negative number, or subtract a positive number from a negative number, etc. So how do I teach that in the classroom? We teach it using economics concepts or personal. The way we taught it was we taught cash flow. We gave them a really interesting cash flow problem, a simple cash flow problem, and we said, here's a student, and here's how he manages his money, and he decides to buy this car that he can't afford, and he's just making his budget, and then he gets a girlfriend, the girlfriend wants to go out to eat. So these are very interesting examples. All they're doing is addition and subtraction, and we can give them two negative numbers and things like that, and they don't know it, but we've taught them cash flow, and we've taught them addition and subtraction. So that's how we're kind of trying to sneak it in. This was an example. So the other example I used was net worth. This was a wonderful chart, and this again teaches them how to read charts. This was something that was in the Young Invincibles report, and this was just in 2016, and this is looking at the median wealth of 25 to 34-year-olds, and they're just on that cusp. This is going to be them in a couple of years, and it's so interesting. The data shows that if you have a college degree and student debt in 2016, you will do worse in terms of net worth than somebody who doesn't have a college degree at all. This was eye-opening for them. And so this is very interesting data. This is some stuff that interests them. And through teaching them stuff like net worth, then we talk about what is net worth, and then we do some problems on net worth, and all they're doing is adding and subtracting. And so we get them to learn the basic stuff. And this is how the semester begins, and we move on. Here's another question. So again, ripped from the headlines. So the Bush administration had announced that they were giving aid to soybean farmers who had been affected by the tariffs. And so I think the actual amount of aid was something like $4.7 billion, but we're rounding numbers off because they don't have calculators, right? So we want to give them easy numbers to use. So I made that $5 billion. I said the US population is roughly around 300 million, but really I want to know who's actually paying for this is US taxpayers, and people who are working and paying taxes are paying for this. So what is the cost per worker in the US? So this is very interesting to them. It teaches them about where the government gets its revenues from, and then what is the actual cost of some policy like this. And this was actually a clicker question. I didn't have space on the slide to put in the question, but this is the kind of stuff we're doing, and they're interested. They want to know because it was just in the newspaper today. So they're very interested in knowing this. Think about what happened, when they talked about the article on the Trump organization and the fact that Mr. Trump had received all the $413 million of today's dollars. And that was immediately, I walked into the class and I said, you forget the politics of all of this. What do they mean by today's dollars? This is in the newspaper. All of us who read the newspaper should be able to understand what the newspaper says. As an adult, when you graduate from college, you're expected to understand what's in the newspaper. What does today's dollars mean? And then it was really interesting because Mr. Trump followed it up with a tweet. And on Twitter, he said something about the failing New York Times and bringing up this same old topic, the tired topic. And he said, it was interesting that they were talking about the time value of money. So on Twitter, all of this was trending, which was very interesting. Again, here's what's going on in social media. So do you understand what is the difference between time value of money and what they're talking about here, which is today's dollars? And so immediately there's a discussion. We can talk about inflation, how we calculate it, what is time value of money, why is it important, et cetera, et cetera. So it's not hard to find topics like this that are very interesting to students. One of the things that helps us, so all of that is fun, but we find that it is really tough. These guys are very weak in math. So we don't really know. We've made a promise to them that they're going to be ready for micro. How can I make sure that I actually fulfill that promise? So one of the things that we're doing is ongoing assessment. We give them weekly quizzes, and we're tracking the weekly quizzes. So here's our first quiz. You can see question 1 was on order of operations. The second question had 2 parts. It was on opportunity cost. And so I have data. This is a big chart, a big Excel file. My TAs are keeping track of the data. And I see that the question that they did worst on was these large numbers questions, where we're asking them to go from thousands to millions, millions to billions, or I just give them a number and ask them to convert it into millions, and these are the questions that they did worst on. So we've tracked that. Notice I've got an extra question up here. It's extra credit. It's worth 1 point. And these are slightly harder questions, and I've got them in there because I know that students who are weak in math are also very slow at math, and we're trying to speed them up, because when they get into micro, many of them don't get through exams because they're just so slow at doing it. So we want to improve their speed, and if they get that problem, they get that 1 point. So we're trying to see who can't do those questions, and then we call them in, and then we give them some guidance on how to improve their speed on tests, et cetera, because we know that that's going to help them. So we noted this, that they were weak in converting large numbers. So I went back into class that week, and then I said, okay, so we saw that they didn't know how to set up the problems, how to do the conversion. They all sort of do it by gut feel, whether it's right or wrong. And so I said, here's a way to think about it. You can think about it as proportions, or you can write out the equation this way. So we gave them a framework to use. And then we gave them a second quiz, and we had the same questions on the next week's quiz. We had a couple of large numbers questions. And notice what happened was, well, they missed the fraction to percentage question. They all did that. And then again, they missed the large numbers questions. So I had gone back into class and done the explanation, and I thought they were going to do great on it. So we were like, what is happening? We just explained everything. We knew they were studying. So then I started talking to students one by one, and then we realized that they didn't know what to do with decimals. They didn't know which way the decimal moves when you multiply by 10 and which way the decimal moves when you divide by 10. So these are the kind of basic math pieces that they're missing. So then we went back into the classroom or talked to individual students, went through some examples, and showed them the rules for what happens when you multiply by 10 or divide by 10. And then the next quiz, everybody did great. So it takes some time. This is what we call ongoing assessment. So often when we think of assessment, it's at the end of the semester, by which time it's too late to actually do anything. But this is ongoing assessment that we're doing to collect the data. Some nudges are very helpful. We don't do office hours anymore. We do what we call study sessions. The TAs don't offer random office hours. We have every night, the same time, 5 o'clock to 7 o'clock. They can get help. It's always in the same room. All of this makes it much easier for students to come and get help. And they come. A large number of them come. We track them. We're looking at the study sessions. We're tracking how many people are coming in every day. I go into class and I tell the students, well, this is how many students came in last week. You know, the numbers are increasing. And all of a sudden, if I say that, they think they ought to be going as well. And then we saw the numbers double the next week. So this is very helpful when they come in for help. We can see whether they're coming. We can compare this to their quiz scores to see whether coming to the study sessions helps. We saw that, in fact, quiz scores were improving. I was able to report on that in class to the students, and then they realized, okay, maybe I ought to be going to study sessions as well. So what did we learn? I'm not a math person. What we've learned is that somehow this idea that numeracy is cute, and it's kind of okay to be innumerate. You wouldn't tell people that you couldn't read or that you couldn't write, but apparently it's perfectly okay to tell people that you can't do math. And there was a wonderful article on this in the Financial Times talking about that woman in England who was the Home Secretary when she was being interviewed. And somebody asked her, they were going to hire 10,000 more police, and somebody said, what is the cost of that going to be to, per policeman to the city? And she couldn't do that calculation on live television. And they were talking about how embarrassing it was and that it isn't cute, and at some point in your career that you're going to do it. They also have this thing that what we're learning is high math, that what we're expecting in economics is very high-level math. I used to get mad when people used to come into my office and say, I'm not a math person, and I would think to myself, then why are you here? But now when they say I'm not a math person, I say, oh, good, I'm not either. I'm an economist. So let's go ahead and learn this stuff together. And that we don't think, we're not interested in math, we're economists, we want to know about the economics, we want to understand what's going on in the real world, and we think of math as a tool. We're certainly not math people, we are just economists. What we have found is that there are some basic math facts that students have not learned or memorized. We assume that. For instance, many of the students don't know their multiplications tables up to 12 times 12, and that's what's holding them back in doing the calculations and being really slow. This is something that we're working on in the classroom. We're trying to teach them that there are some facts they absolutely have to know and memorize, and some facts that they have, and then there are procedural things like problem solving has to be logical and they have to think through it, but there are some basic things they have to know. There was a wonderful article in Nautilus, I'll be happy to talk to somebody about that, about a woman who did horribly in math up to the high school level at the college level, and then decided she wanted to go into engineering, and then went back to scratch at the age of 26 and learned all that math again, and her views on what it took to learn that math. Weekly quizzes, it helps us capture data and discuss the data with students. Small nudges make a difference. I used to give them sets and sets of homework problems, and they were called practice problems. Nobody ever did the practice problems. And then I said, you know what, guys, I'm going to give you study guides for every quiz. All I did was change the name, and all of a sudden they were, oh, thank you, Professor Foster. And everybody was doing the study guides, all the problems. Exactly the same thing, just change the name. Instead of office hours, we have study sessions. Makes a big difference. Just changing the name. It makes it sound so, I don't know, more friendly, I guess. We're doing helping them with speed. What we have learned is that many students will say, I'm spending a lot of time studying, I'm spending a lot of studying. They're doing stuff, but they don't learn. So this is something that we're really helping students with learning. And I work with them a lot on this, on the difference between just doing stuff for completion and then actually going back and doing metacognition and learning the material. So that is something they have not learned in high school. Summative assessment. Okay, so this is at the end of the semester finally. We've done the formative assessment, the diagnostic testing. All through the semester we're doing the testing iteratively on the quizzes and the other stuff. And then at the end of the semester, how did we do? Did we actually achieve our goal? Did we teach the students anything? And how did they perform in micro the next semester? So there are lots of different ways of doing summative assessment at the end of the semester. A lot of the things I've seen I haven't liked. I think the most effective ways of doing summative assessment for any course is having a pre-test at the beginning of the semester and a post-test at the end of the semester. That's very effective. It'll show you whether you move the needle. In our case in econ, I sometimes think the best way to do summative assessment is to see how do they do in the next course. So if you're teaching principles of microeconomics, really it's not how they do it the final exam on your exam, but it's how they do in intermediate micro the next semester. That will really tell you how effective you've been as an instructor. So we collected the data. This was the first time we taught the course was in fall of 2016. And after teaching the course, I actually taught the micro course the next semester, and I wanted to see, did we do a good job? Did we deliver on our promise to get them ready for the course? And so we collected the data and compared them with the students the next semester who never had to take any the Principles of Mathematics course. So here are our results. This is in spring of 2017. This is the micro cumulative final exam. So it's covering everything that that they did over the entire semester. And here is the final exam score. And we look at final exam scores, not the course grade, for obvious reasons. Course grade has a lot of fluff in it. And so we're just looking at the cumulative final exam score. So let's look at the last row first. These are people who didn't need to take the mathematics prep class. These are people who are already strong in math. And this is their average was 74% on this exam. And then at the very top, on the top rows, everyone who had to take the mathematics prep class. And on average, their score was a 63.9, so about 10 points off, not great. We weren't thrilled with that result. And then we broke it down by by the different grades that people got. And then we looked at people who had passed the math prep class with at least a grade of C. And we saw that they did considerably better, about a 67.48. And then we saw the people who passed the prep class with at least a grade of a B minus did pretty well. I mean, they were up in the C's and almost mid-C's. And so this was very informative for us. Earlier, we had said that if anyone took the math course and got a C minus, we would allow them into micro. After looking at this data, we said, no, you need to get at least a B minus in the math prep course for us to take you into micro. And so this semester, when I'm teaching the class, I'm very cognizant of this data. We are working hard with the students to actually get them to where they need to be so that they do well in microeconomics. Student comments. What did students think about the course? We were so nervous. The semester was actually a very tough semester because we were going into this absolutely raw. I was dead nervous about teaching. Student comments. I think this course was a great opportunity to learn the algebra and geometry. Students are taught from the extreme basics how to solve problems. They think that this was very satisfying. This is something we wanted to see. I loved the last comment. That was the comment that told me everything, that they wanted to learn and they wanted more stuff. We didn't have a textbook. We were creating all the materials ourselves, so we didn't have enough materials the first time we taught it. So since then, we've created a lot more materials for this course, and students are working on it and seem to like the materials. So.